So I want to start with really, we're going to go ahead and put this definition up here. This is all on your formula sheet. We're looking today at something called a z-score. And this is very common. We will use it for the rest of the semester. You have two different formulas, just really if you're dealing with a population or a sample, but it's kind of the same thing. So if you're looking at under chapter 3 on your formula sheet, the right-hand column, it's a little over halfway down there. If I'm looking at a population, x would be our given value minus mu, which is the mean, divided by sigma, which is the standard deviation. It's the same idea in a sample. Just remember, if we're dealing with a sample, we have different letters to represent mean and standard deviation. So it's always our value minus the mean divided by the standard deviation of our set. The z-score doesn't have a unit. It is telling us how many standard deviations something is from the mean. The purpose of a z-score is to allow us to compare different sets of data. Sometimes it's easy to compare two things if I want to say, okay, well, this test I got a 90% on, this test I got an 80% on. Which one's better? Okay, but if you look at the class average, maybe you got a 90%, but the class average was 95. And maybe the other one you got an 80%, but the class average was 60. Okay, then how do you compare it? Like you got a higher percent, but on this one, your higher percentage, you did worse than the rest of the class, but here your lower grade was better than the rest of the class. So the z-score is kind of a way to level the playing field. We put everything in terms of the same unit. So it's essentially just measuring how far something is from zero. If we think about it in terms of like this bell curve, this picture that I gave you, a z-score is telling you how many standard deviations you are from average. So this is your mean, x bar or mu if you're dealing with a population. So if I say you have a z-score of +2, that means you are up here. You are 2 standard deviations above average. If I say your z-score is -3, then you are all the way down here, 3 standard deviations below average. So a lot of times our z-score is going to be something between -3 and +3. It doesn't have to be, but this is kind of where most things will fall. So a positive standard deviation, you are above average. Negative would be below. It's just how many standard deviations are you from the mean. Does that make sense? So let's look at an example and try to interpret this. The mean height of males 20 years or older is 69.1 inches with a standard deviation of 2.8 inches. The mean height of females 20 years or older is 63.7 inches with a standard deviation of 2.7. Who is relatively taller? So we're not just saying who is taller. Who is taller with respect to other people in their age group? All right, so if I look at this, we have 2 different people. So we are going to find a z-score for each of them so that we can compare them. Now for each one, we need the mean and standard deviation for Alright, Kevin is a male. So what is the mean height for the males? 0.1, and standard deviation for that group would be 2.8. Okay, Candace, female, so the mean height for the females, 63.7, standard deviation of 2.7. So I took all the numbers given up there and kind of broke them into their groups. So now our value, if we're dealing with Kevin, his height was 83. So if I'm looking for his z-score, it's his value minus the mean divided by standard deviation. This is his z. So we get a z-score of 4.96. Okay, what that means is, in terms of his group, he is almost 5 standard deviations above average. So he is way out here. Very unusual to be that high. If we look at hers, so her height was 76. So if we find her value, her mean, or her height minus the mean divided by standard deviation for her group. So we get 4.5 repeating, so 4.56. Typically we round a z-score to 2 decimal places. Okay, so both of these are pretty high numbers. They are both above average. My question was who was taller, so that would be more above average. So who would that be? Kevin. He has a higher standard deviation, so he is further above the mean for his group. Does that make sense to everyone? We do have to pay attention to the context of the problem to know like which z-score was better. So for instance, if I was comparing winners at the cross country meet today, the female winner and the male winner, okay? If I found each of their z-scores, would I want a higher z-score or a lower? Because a higher one would mean, in terms of the time it took them to run, it took them more than the average person. So in a race, you want to be faster, you want to be below average. So you would be looking for who was more below. So you just kind of pay attention to the context of the problem, whether you're wanting the biggest or the smallest number in terms of who did better. All right, do we need more problems like that? No, okay with that. The second thing we need to talk about today is a percentile. Do you want me to let you write for a second and then I'll talk? You guys have all taken a standardized test before. And you get your results back and it says you scored in the 75th percentile or in the 81st percentile. That's what this is. It's telling you that your score, or if you're in like the 80th percentile, it means 80% of the scores are less than or equal to your score. Okay, so if 80% are less than or equal to, that means 20% did better than you did. So we can when we see percentiles, a lot of times you'll see a capital P with a subscript telling you what percentile. So if I said the 10th percentile, that means if the numbers were put in order, 10% are less than or equal to this one number, which means 90% would be above. So the key there is less than or equal to. So first I just want to do an example of trying to interpret it. How would we write a sentence explaining what this means, and then we'll actually calculate a couple percentiles. So this one, you don't necessarily have to write all this down. I just want to read a scenario and make sure we can write a sentence to explain it. The Graduate Record Examination, GRE, is a test required for admission to many U.S. grad schools. The University of Pittsburgh Graduate School of Public Health requires a GRE score no less than the 70th percentile for admission into their human genetics program. Interpret this. So this is the way a lot of those are set up. It's not like you have to get a certain score. It's just they want to take the best people taking this test. And so you have to have a score no less than 70th percentile. So who gets accepted? Yeah. So there are different ways you could write this, but you could say the top 30% of scores would be accepted. Okay, so if you were in that range, you get in. If you were below that, you would not. Your score has to be high enough that if you score better than at least 70% of it. We will look at percentiles most frequently in talking about quartiles. Have you guys ever talked about quartiles before? Okay. So this will lead us into the next section. We're going to look at box and whisker plots a little bit. But quartile basically breaks your data into foods. So you have the 25th quartile, or 25th percentile is the first quartile. The 50th percentile is the second quartile, and so forth. That's what we are going to be finding. We have already been doing some of this. The median is the middle of our data. That's the same thing as the second quartile, or you could call that the 50th percentile. The first quartile is the 25th percentile. Third quartile would be the 75th percentile. So those are what we will be finding quartiles 1, 2, and 3 in a lot of our sets of data. So let's actually look at a graph. I'm going to give us a set of data. The thing to remember, when we found the median, what did we have to do to our data first? We had to put it in order. So if we're finding quartiles, our data has to be in order. So if I were writing this down, all I would probably write down would be this set, and you can even, if we look at it, this is a group of students collected data on the speed of vehicles going through a construction zone when the posted speed was 25 miles per hour. Here are 14 randomly selected vehicles. Find and interpret the quartile. So I did go ahead and get the data to you in order. If I hadn't, you would have to put it in order, small to large. Okay. The easiest quartile to find is quartile 2, because we've already done it. Quartile 2 is what? The median, the middle. So if we went through and found the middle, values. What do we do if there's two values in the middle? So our second quartile is 31.5. Not 31, 32.5. Okay. Then, once you have that first quartile, so it was right in the middle of these. Essentially, all we have to do then is find the median of the bottom and the median of the top, and that will give us our other two quartiles. So since the middle is right in between them, when I'm trying to find the median down here, it would be 28. So our first quartile is 28. And again, if it were two values, you would just add them up and divide by 2. What would our quartile 3 be? 38. If I ask you to interpret, I did on this example, but usually I wouldn't have you interpret all of them. So this tells us quartile 1, 28, that means 25% of the speeds were less than or equal to 28 miles per hour. Okay, the next one, what would quartile 2 mean? 50% of the speeds. And I'm not going to write the last one, but what would that last sentence mean? Yes, 75% of the speeds were less than or equal to 38 miles per hour. Or on the flip side, you could say 25% of the speeds were above 38 miles per hour. Different ways you could write that. All right. Are there questions on this? Okay, let's do, we're doing pretty good on time. Do you guys care if I do just a couple more slides and then I'll stop for today? I want to do another definition and example with it, and then we'll stop. The next thing we have to find is also on your formula sheet, interquartile range. So it's basically the window where 50% of your data lies. So it's IQR, interquartile range. It's just quartile 3 minus quartile 1. So just like finding a range is your high minus your low. We're just subtracting our quartiles here. So if I asked you to find the interquartile range of our data, So that's quartile 3, which was 38, minus quartile 1 is 28, and we get 10. So our interquartile range is 10. All that means is there is a 10 mile per hour difference. Between quartile 3 and quartile 1. Or you could say 50% of your points are within 10 miles per hour of one another. I think that's where I'm going to stop for today. So tomorrow we're really just going to talk about outliers, and I might start the next section depending on how we're doing. So I have a handout. This is the assignment for both today and tomorrow, so it won't be due until Thursday. The front page is all finding